What if I told you your brain learns to lie and gets better at it the more you do it? Scientists have discovered something fascinating about deception, and it might change the way you think about honesty forever. We're diving deep into the science of lying, from a child's first fib to the complex ways our brains adapt to dishonesty. Stay with me, because what we uncover today might make you think twice before telling even a tiny white lie. Let's start at the very beginning. When do we learn to lie? You might be surprised to hear that it begins incredibly early. Most children start telling their first lies around the age of 2 or 3. The classic, I didn't eat the cookie with chocolate smeared all over their face. Now, before you panic, this is actually a positive sign. Psychologists say that lying is a significant milestone in a child's cognitive development. It shows that they're starting to understand a critical concept, that other people have different thoughts, beliefs, and knowledge than they do. This is called theory of mind. To tell a lie, a child has to understand what you know, what they know, and how to create a different reality in your mind. It requires memory, planning, and a basic form of empathy, understanding someone else's mental state. So, in a strange way, a child's first lie isn't a moral failing. It's a sign that their brain is growing more complex and sophisticated. It's the first step on a long road of social navigation. And it all starts with a simple, often transparent fib. So, if lying starts as a developmental milestone, what's actually happening inside our brains when we deceive someone? This is where it gets really interesting. Researchers, including those from University College London, have conducted studies using fMRI scans to watch the brain in the act of lying. They found that a specific part of the brain, the amygdala, plays a huge role. The amygdala is our brain's emotional center. It's responsible for feelings like fear, guilt, and anxiety, the very emotions you might feel when you tell a lie for the first time. In these studies, when participants told their first lie for personal gain, their amygdala lit up like a Christmas tree. It was firing off signals of emotional distress. But here's the crucial part. As the participants continued to lie repeatedly, the amygdala's response became weaker and weaker with each new lie. It's a process called neural adaptation. Essentially, the brain gets used to the act of lying. The negative emotional feedback that initially made them feel bad starts to fade away. This desensitization makes it emotionally easier to lie the next time and the time after that. Your brain literally adapts to dishonesty, reducing the internal emotional cost of telling a lie. This brain adaptation helps explain the psychology behind why we lie. At its core, deception is often a tool for navigating the social world. People lie for a myriad of reasons. Sometimes it is to avoid punishment, like a child denying they broke a vase or an employee covering up a mistake at work. Other times, it's to protect our ego. We might exaggerate our accomplishments or tell a story that paints us in a better light. This is about managing how others see us and, by extension, how we see ourselves. And of course, people lie to gain a tangible advantage, whether it's in a business negotiation or a personal relationship. But not all lies are created equal. We often distinguish between so-called white lies and big lies. White lies are the small, prosocial fibs we tell to avoid hurting someone's feelings. Think about telling a friend you love their new haircut, even if you don't. These are generally seen as harmless, a kind of social lubricant. Big lies, on the other hand, are deceptions with significant consequences, meant to mislead for major personal gain or to cover up serious wrongdoing. The problem is, as our brains adapt, the line between a small lie and a big one can start to blur. What starts as a harmless white lie can slowly pave the way for more significant deceptions because the brain mechanism is the same. This brings us to the dangerous cycle of habitual lying. As the amygdala's response diminishes, our moral reasoning begins to get rewired. What once felt wrong starts to feel less wrong. Or maybe it just stops feeling like anything at all. Scientific American put it perfectly. Each lie makes the next one easier. This creates a slippery slope. A small lie told to avoid a minor inconvenience can escalate. If you get away with it, the brain learns that lying is an effective strategy with minimal emotional downside. The next time a similar situation arises, the barrier to lying is lower. Over time, this can lead to a pattern where deception becomes a default response rather than a last resort. This isn't just a theory. It's a neurological reality. The brain is an incredibly efficient learning machine. It seeks the path of least resistance. And if lying consistently provides a reward like avoiding conflict or gaining an advantage without the negative feedback from the amygdala, it will reinforce that behavior. This is how a person can slowly transform from someone who only tells occasional white lies into a habitual liar, often without even realizing the shift is happening. Their moral compass has been slowly but surely recalibrated by their own brain. It's a powerful reminder that our actions don't just shape our reputation, they physically shape the neural pathways in our head. So, where does this leave us? We've seen that lying is a complex part of human development, a behavior rooted in our brain's intricate wiring. We start lying as a sign of cognitive growth. But through a process of neural adaptation, our brains can become desensitized to dishonesty. This can create a dangerous cycle where small fibs pave the way for bigger ones, gradually eroding our internal moral compass. The science is clear. Our brains are constantly learning from our choices, especially when it comes to honesty. So the next time you're tempted to twist the truth, even just a little, remember what's happening inside your head. Your brain is learning. The question is, what do you want it to learn? Thank you so much for joining me on this deep dive into the science of deception. If you found this as fascinating as I did, please hit that like button and subscribe for more content that makes you think. I'd love to hear your thoughts in the comments below. Have you ever caught yourself on that slippery slope? Let's talk about it. Until next time, stay curious.